As I told you, variables and parameters are local whenever you're declaring inside a function. Function calling is really important. Otherwise, you cannot use that function. Even if you have written a large number of code or maybe 1,000 lines of code for the function, if you're not calling, it is useless. And by default, not by default, like whenever you're writing a function, it should return something. If you're not returning, by default, it returns what? A none, right? So make sure you return from your function. And what's the purpose of any function? To do something. You have the input. You need to pass those input through the parameter. Whenever you're calling, use those parameters as an argument. Inside the function, do the operation, finally returns the output. Do not print anything inside a function except the main function. Make sense? This is the important thing. And make sure you write the docstring for a function so that it is easier for you or for the other developer to know what you have written inside the function. And what's in the docstring or the documentation? It's just like a comment. What is function, like what this function is doing, what are the input, whether you use positional parameter, what is the order, what's the output, what is the type of the input and output, such and such. And maybe it's like single line of what you are doing inside the function. For example, if you have an add function, if it takes 2 parameter, you can write, well, this function takes 2 parameter. First one is the operand 1, second one is the operand 2. Both are float type. The function is doing the addition operation, and finally it returns the result. That's it for the addition function. For encoding, depending on the parameter, you need to write those things like this function takes this, and finally it returns a cipher. And how you're working a little bit about those things. Maybe whenever you are shifting the value, it may wrap up from Z to A. How you're doing, you can just write with some simple wording. Stack diagram and the traceback. Stack diagram is like whenever you are calling a function or function within a function, it calls the inner function first. Like it executes the inner function first. After finish executing the inner function, then it go back to the outer function. I already have shown you. If you need to read it, you can read either module 5 or module 2. Both in both module, I have added those information. The traceback is the same thing. Whenever you need to find an error, like not find an error, whenever you have an error to find where it is, you need to trace it back. So go from bottom, then go from top actually, but it works from the bottom, line by line. Like for example, you're calling a function called like greet, it calls another function, then another function, and there is a problem. So it just write this way, like first greet, then another function, then another function, then the exact error. The return values and conditionals, as I told you, there might be multiple return statements in your function, but you need to write those things in a conditional statement. The conditional is like multiple branches or single branches or like 2 branches. But you know, whenever it goes one branch, it never go to the other branch. So you can return from that branch. That is totally fine. Boolean function and leap of faith is like by default with the function name, we have a faith like, well, this function, if it is true, then we can do these things. And those function typically returns a Boolean value, either true or false. For example, if I'm checking whether a number is an odd or even, if I'm writing a function called like is odd, it just return true. That means the value is odd. Then I can work the next one. Sometimes you need to check the function, whether it takes this particular type of parameter. To know these things, the function name is instance. So there is no underscore here. Altogether is instance. And the last one is the program structure. When you're writing a functional programming, you need to structure your code. The very first one is the docstring of your program, what you are doing in that program. For example, it is a project 1, you are the author. in which day you have done these works, and what you're doing in that project. The first doc string. This is the program doc string, not the function doc string. Then, if you are importing some libraries, you need to import those libraries in the global section. What is the global section? The section is not under any block. That means whenever you are writing a function, they are under that functional block or function block. This is not a global code. This is the local code for that particular function. Only the global code is like import things. And for this project and next onward project, you are not supposed to write anything inside the global section. You need to write everything inside a function or any block like if block. Then you need to write your user defined function. Depending on the utility, you need to write your own function. So if you don't know what it does or what you need to write the details of the function, just write the function name and write the doc string and then pass, and later you will write those functions. And whenever you are done with the user defined function, you have to have a main function. And what's the purpose of the main function? The main function takes the input, do the processing through the utility function, and then prints the output. That's it. And the very final thing is like, you need to call the main function. You need to call the main function in a, what's that? Exact name. The main function with conditional execution, like if underscore underscore name equal underscore underscore main. And as I told you, you need to memorize this syntax. You don't need to know what it does or how it works. As for this course, you don't need to, just write this syntax. Okay. Any question at this point? No? Okay. So today we will discuss some other concept. I will discuss different types of parameters: positional, default, keyword, or the name, variable positional, variable keyword, keyword only, and positional only. But for this course, you don't need to go beyond 5. So positional, default, keyword, variable positional is fine. But sometimes you need to use variable keyword, but not the 6 and 7. But at least you need to know that these are the types. And here is a summary of all 7 types. As I told you, when is a variable positional, just 1 asterisk, and args is a variable name, but this is like a convention. You can write a different word here, different parameter name here. Same thing for the variable keyword. This is like double asterisk, and keyword args. Again, this is the convention. Whenever you're writing KW args, anyone can understand that this is like a variable keyword type argument, but you can rename it or you can use a different name here. When it's the keyword only, so after the positional, you need to write the asterisk, then the keyword only. For the positional, pass the positional, then forward slash, then the parameters before the forward slash must be passed positional. That means here's the other way. You need to write all positional before the forward slash. But for the keyword, parameter after that asterisk must be passed using the keyword. But as I told you, you don't need to use those things for this class, but at least you should know those things. Okay, I told you that a function can call another function. For an example, I am writing a function called like a calculator, and there's some small task in the calculator. My main function is the calculator. Maybe I ask you to create a calculator that can calculate general calculation as well as scientific calculation. So you may have written like 2 types of function. One is like general calculation, and there is like scientific calculation, like 2 functions. Inside the general calculation, or maybe the scientific calculation, there are some small tests, like one for finding the sin x, one for finding the like trigonometrical things, another is for what, maybe some other things like degree conversion or some other things. So you can write some small function there, but not inside the function. Maybe you can write this function outside of the function. Whenever you need it, you can call those things from that function. That means you can always call a function within a function. And as I told you, as a stack diagram, whenever you're calling a function from a function, the inner function should execute first before going to the outer one. Then the two important things, one is encapsulation and generalization, and that is refactoring. And what's the encapsulation? Reusability. For example, I ask you to write hello world 100 times. So it's not a good choice to write just print hello world 100 times, like 100 lines. Maybe you can write a loop. With that loop, you can just print those things. Other ways, like, well, not the hello world. I ask you hello a name, like some dynamic things, not the hello world. Since it's the name, probably in a for loop, it is really tough for you to vary the name. What you can do, you can write a function. In that function, it takes the name and then prints the output. Now, you need to call that function maybe 100 times. In that case, you have a for loop, call the function from the for loop, and that function actually prints hello, and the name is specified through the argument and the parameter. Let me show you some examples that make more sense, I guess. So encapsulations, yeah, like two things. I'm just writing welcome and have a great day. If I'm going to write those things like 5 times, it would be like how many lines? 10 lines of code. Instead, I can write here like, well, I have a function. In that function, I'm just writing those two things and then call the function 5 times. Maybe more specific. Like a more specific, I can write here like print hello and print maybe the name. So for my case, I'm just writing my name. And if I'm going to print those things 3 times, it's like 6 lines of code, right? Instead, if I can write a function called like, well, definitely the name should be different for different cases. Like these are the 3 names. So if I'm writing a function called like greet and then print those things. So first, I would like to go through the static one, like every time I'm calling this. Instead of 6 lines of code, I have written 3 lines of code and then call the function. How many times? 3 times. So as of now, we have like same lines of code, 6 lines and 6 lines. How about if I'm writing these things 12 times, like 6 times, like 12 lines of code, right? Here, 6 times, and then 3 lines of code, 9 lines. So 12 versus 9. So I'm just giving you some comparison. Like whenever you are encapsulating everything in a function, it always saves some lines of code, and it is like some hidden things. So this is like an encapsulation. And what's the generalization? The generalization is like, well, I would like to print different name here. Like those 3 names. So now instead of the name, I can print a name. And here's my variable name. And here I'm putting like, well, you need to print these things. So this is basically a generalization. So we'll generalize a function which can serve different purposes like writing variation by just passing the parameter. Do you see the difference between encapsulation and generalization? Generalization is like more like not a specific task. It can be worked in different tasks. Like it can write different names. And encapsulation is like we are doing the same thing. Instead of doing the same thing, we're just calling the function in a functional way. Now for the refactoring, so here's the encapsulation version. I don't know what's the example of the generalization. Yeah, generalization, same example. So I'm just writing hello Alice. This is like a generalization things, but every time it will print hello Alice. But instead of just the static name, I'm passing the variable and make it generalized purposes so that it will print hello the name. So this is called a generalization. So whenever we are writing a function, first we need to take care of like encapsulation part, how we can condense it, and then can we make it for general purpose things, not for one task. Like for example, I'm writing a function that can add 2 numbers. Now, can I write a function so that it can add 3 numbers, multiple numbers? So this is like a generalization. Okay, and what's the refactoring? Refactoring is the process of improving the structure and readability of code without changing what the parameter does. And the goal of the refactoring is to make code easier to read, easier to fix, and easier to extend. I hope there's an example here. For example, like the student things. Now, here you can see there is like 9 lines of code. I can just print, but if it is like 50 student, I need to write those 3 things. 3 multiply 45, right? And then I need to make sure. So for example, like this is 59. 59 is like fail. Okay. 58 is fail. But at some point, if I change my grading scale, like, well, 50 up to 55 is pass. That means I need to change all of the instances who got in between 55 to 59. So a lot of changes I need to do, right? Instead, if I can write a function so that it can automatically print based on some condition, like some refactoring things, so that it is more easier for me to fix it. For example, if I'm just changing LY, if it is greater than 60 is pass, I just change to just 55. Just changing 60 to 55, it solves the problem. But if I'm writing this way, if it is like 1,000 students and maybe 50 of them are in that range, I need to change 50 of them. Sometimes I do mistake by hand. So refactoring is really important so that you can easily fix it. It is more readable. Like you can see here, this is not readable things. If it is like 1,000 students, you need to find out why are the 59, why are the 58, why are the 55, and it is hard for you to fix. But this code is more like a readable things like, well, I can just only change here. That's it. I know this is the logic. If it is like more than 55, I will give them the passing grade. Or maybe for A grade. Right now, the A grade is like 94, but I changed my mind. I would like to give you A if you're getting 90. I just change here. So if like 30 of you are getting A, like not A minus, in between the range of 90 to 94, then I need to change all of the 30 students. Instead, I can just change it here, the logic. Okay, so this is like a refactoring. So 3 important things whenever you're writing a function: encapsulation, generalization, and the refactoring. Okay. Any question? Okay. So whenever we'll do some example, then it makes more sense how you're doing those things. But before going to the development plan, I would like to finish other two important things, which is like a function composition. I hope you already have used function composition. Well, here's an example of encapsulation versus refactoring about the calculate average. Let's see what it does. In the calculate average, this is like an example of calculating the average. I have a function, calculate average. It takes two numbers. While true, that means taking the input, then until Q, it takes the input and checks whether it's a digit or not. If it is a digit, if it is not a digit, it is continuing. That means it is asking the same thing again. Continue means like it will never execute the rest of the code, go back to the next iteration. So since it's an infinite loop, in the next iteration is like again asking the user's input. Then if it is not, then we have a number and we're checking whether the number is less than 0. If it is a positive, if it is a negative number, we are again throwing to the user's input. They need to enter a positive number. If it is not, we're adding that number to the total and a counter. When the count is 0, that means there is no value they entered here. Where it is not, then we're dividing by 2, right? This is a very simple function. Now, this is sort of like an encapsulation. We're encapsulating everything inside a function called like calculate average. We have a large number of code, like large number of lines of code that are doing multiple tasks. One is doing calculating average, one is doing calculating the standard deviation, another is calculating the medium, minimum, and maximum. Now, if you're writing everything all together, then probably it is really hard for you to find where you need to change for the calculate average things. That's why we're encapsulating one task into a function like calculate average. Now, refactoring is like, well, can we just subgroup those problems, like sub problem? Like this is our problem. Our problem is finding the average. What are the sub problems? Can you divide those things in a sub problem? Anyone? So this is like a problem. So problem is like our like whenever the user is asking something, like our project specification is the problem. So this is our problem. Our main problem is calculating the average. So I am solving this problem. Now, do we have any sub problem here? Can you divide in different sub problems? Well, see, if I'm asking you just naively, find the calculate, like find the average. Then you ask me what average, right? Some number. Which number? Well, 10 numbers. This is a sub problem, right? How many numbers? Well, 10 numbers. What are those? Are they positive, negative, or anything? Well, those are positive. Then, is there any other character other than the numbers in that file or in that document? No. Like those are like sub problems. Now, if I'm solving this problem, do we have any sub problem here? Can you write some small function with those sub problems? This is basically the refactoring. If you cannot find it, that means we're done. If you can find it, then we need to refactor it. Yes, we can find it. First is the user's input, right? Until this point, we need to validate this is the user's input. What are the other things? We need to check whether it's a digit or not. Then the other problem is like whether it's a positive or not. When we have solved those problems, only then we can calculate those things. Now, if I write those things in a problematic way, like this way, is valid positive number, then I'm just changing here is valid positive number, a function which is returning it is a valid number and a positive number. So this is the valid number and this is the positive number. So I'm replacing this one here. If it is not, then false. And then the calculation, just the calculation part, this last part. If the count is 0, we're not returning anything, like return none, otherwise we're doing the calculation. Now in the main function, what you can do, we can just write two sub-problem here, collect numbers and calculate the average. For the collect number function, what it does, collect number function, taking the input, and inside that function, it calls the is valid positive number. There is another function here, which checks whether it's valid or not. If it is valid, it returns the total and the count. So the collect function gets the total and the count. Whenever we have the total and the count, we're sending those information to the calculate average function. Now the calculate average function is like very small right now. It's like only 3 lines of code. We're just calculating the average. That's it. We're not taking the input. Now whenever we're done, we have the average. If the average is none, like when we don't have anything, it returns none. The none means like there's no number entered. If it is not, then we're printing the average. What's the benefit? The benefit is like each function is doing their own job. One is doing checking the number, one is doing collecting the number, and is doing the calculation. Reusability, yes, we can reuse this function for a different purposes. Like, so if you are just taking the input inside the calculate function or like the average function always, then probably finding the median, we cannot use it. We cannot reuse it. If we have a function separately for getting the number, we can reuse it in average calculation. We can reuse it for median calculation. Same thing for the validation checking. If we have a number validation checking, we can reuse it in both functions. That means we don't write the same thing in 2 different functions. So it is like reusability. And another benefit is like testability. We can easily test it. Like, well, if it is not a valid number, then we are getting the error from that function. So other functions are doing fine. We don't need to worry about the other function. But if you're writing everything inside the calculate average function, it will raise an error from that particular function. Like there is an error from the calculate average function. You will be overwhelmed. Why I'm getting wrong. But if you're getting an error from is valid number, that means, well, there's a problem with the is valid function. I don't need to worry about the other functions right now. And to fix it, that one. So this is the benefit, testability. You can easily test it. Okay, so function composition. I hope you already have used the function composition, but I would like to tell you what is a function composition. Function composition is like you can call one function with another function. We already have done these things. This ability to build function by using other function is called the composition. We're calling function inside a function. For example, we would like to find, we need to calculate a radius. What is the radius of a circle? The distance from the center to any perimeter, right? That means the distance from the center point to the perimeter point. That's what we have written here. Here's a function called like distance. I have 2 points, one for the center, one for the perimeter. I have the dx and dy, and we have to square it, just the square root. So square root and then the result. This will return the square root of x1 minus x2 over square plus y1 minus y2 over square, right? This is the function, the formula to find the distance of 2 points. Now, I need to find the area of a circle. I have the radius. How do I generate the area? It's the pi r power square, right? So I can write a function here like, well, this is the area. I need to know the radius. So here's the pi, then the radius, then square. Then results the area, right? Now I have a main function here. So I can just write these things like, well, first I will generate the radius. Then I will send the radius to the area function. I will get the result. Instead, what I can do, I know this radius is doing these things, right? I'm replacing this one, like calling a function within a function. That means it will call the inner function first. So it will call the distance function first with those value. It will return a result, which is the radius. Then I have the radius. It will call the area function later with that value. So this is called like function composition. And this is like a traditional way. First, we'll get the radius, then pass that radius. And we're doing those two things all together in a fly. We already have used the print function there, right? You're printing something. So for example, you're printing the, or you have used the int function, like input function. It returns some string, right? And what you're doing, you're converting it to an integer. At your very first project, you have done these things. So this is like a function composition. You're calling the input function to get the value is a string, then convert it back to an integer. Someone write these things like input function returns some value, which you're writing like INP, and then you are converting INP, INT is integer of the input. Those two are the same, but this is the function composition. At least you need to know something here, like to avoid writing multiple lines of code, you can write those things all together in a function composition. Okay. Okay, before going to the development plan, I would like to discuss the input validation. This is the another important things that you need to know for this project and the next project as well. What is the input validation? Whenever you're getting the input, make sure you validate it. For the first project, you haven't. I told you, you don't need to, bless you. We're assuming that it is an integer. But what happened? There is no integer value the user enters. If I'm a layman user, I can enter a string. You're asking me enter a number, I can write TWO instead of 2. Both are valid, but it is not valid in the perspective of your code. You need to handle this input. How you have handled? You have handled it by try and accept, right? What it does, try is trying to convert. If there is an error, it goes to the accept block. This is the first line of validation. Then another type of validation is like, well, by conditional way, like your input is correct, but the crew should be greater than 2, right? Otherwise, you cannot get the exact input. Or the value should be a positive number, not greater than 2, maybe a positive number. You're expecting that it should be at least 3, Mira top and at least 1 crew. That means it should be at least greater than 2 or greater than equal 3, right? The first thing is like it should be a positive number first. How you have validated those things? Writing a conditional. If this is that, then you're proceeding. So this is the second line of validation. The conditional. For example, the age range. Probably age range should start from 1, right? Probably 0 actually. So there's a 0th birthday. And it shouldn't be more than 150. So should be in between 1 to 150. If anyone enters a value below 0 or above 150, it's an invalid. But they are correct number, right? But in this like particular aspect, it is not correct. So you need to validate those ranges through the conditional. The second type of validation. The third type of validation is you already have used these things in your work, like this one, while true. While true means like it is an infinite loop, right? How you can break it? Whenever you have a valid number, Otherwise, you'll keep asking the user. That means you would like to validate the user's input by keep asking it with an infinite loop. So you can validate the input using a loop like an infinite. But unfortunately, you cannot use a for loop here. It's because it is really tough for you to write an infinite for loop. But you can write it. That's a different thing. While is better here to validate the input. So 3 ways to validate the input. First, try and accept. Then, even if it is a valid number, like there is no error, like you can always convert a string to integer. It is an integer number, but not a valid number. Like our crew should be at least 3, or the age should be in between 0 to 150. So you need to validate those things through a conditional. The third way to validate those inputs are using a while loop, an infinite loop. With that infinite loop, you keep asking the user until it enters a valid one. Does that make sense? Any question about the input validation? No? Okay, so the last concept in this functional module is the development plan. What is mean by a development plan? A development plan is a process of writing program. If I'm giving you a problem or a project, how you can solve it? Well, you need to find it out, find the input, find the output, then the process, and then the flow chart, everything, right? But I'm discussing about the process here, how you are developing the process. So to develop the process, you need to do these things. The process we use this chapter is encapsulation generalization. Start by writing a small program with no function definition. Like you have written at the very first program. Like this is the crew number, this is the unit number, then Mira get that portion, top get that portion, and then crew get that portion, and finally you're adding Mira and top with the crew portion, and finally you're adding 3 with the crew portion. That's it, right? These are the steps. So whenever you know the step or you know the steps of your process, just start writing the program, the whole thing. Just one function. Once you get the program working, if it is working, identify a coherent piece of it and encapsulate the piece of function and give it a name. For an example, like input. The first part is the input. Second part can be like, well, I need to give 3 share to crew. Third part is like Mira share, then the crew share, the top share, then the crew share. And then final is the adding all together and print those values. So you need to divide your main problem to sub problems. Then generalize the function by adding appropriate parameter. Maybe you can write one function that can calculate both mirror share and top share based on the parameter. It is like 11% and 30%, but they're doing the same thing, right? If you're just using a parameter, like the percentage, you can use the same function for calculating both mirror share and top share. This is like a generalization. Then repeat step 1 to 3 until you have a set of working function. You need to keep doing those things like refactoring. Whenever you're done, like the 5th one is the look for opportunity to improve the program by refactoring. Keep refactoring. And for example, if you have like similar code in several places, consider refactoring into an appropriate general function. Just like I told you, like you are writing the same statement for mirror share and top share, you can generalize it. Sometimes you need to split it. For example, like number, like input and output. You can write input and output in one function, but you thought like, well, maybe I need to split it up. One for input, one for output. That makes more sense to me. So either you can split it or generalize it. This is also refactoring. So let me show you an example here. Well, the design of a function is two parts. One is the interface and this implementation. Interface is how the function is used, including its name, parameter it takes, and function is supposed to do. And implementation is how the function does what it's supposed to do. If I'm giving an example here, here is a circle. I can calculate a circle, like draw a circle in different way. One of the ways is like, well, if I have the circumference and I know the length of the circumference, I can use a polygon to draw a circle. Or if I have the arc, I can create an arc up to 360 degrees. Like I can draw a circle this way, right? Not a good circle. Then I can round it up. The other way is, if I know the arc, I can just move the arc by 360 degrees. Right? What's the example here? Example is like ask the user for words stop when Q is entered and print the longest word entered. So suppose I'm giving you a problem like, well, you need to find the longest word and make sure you keep asking the user the input again and again until he enters or she enters Q. That means first he enters like A, okay, then ABC, then what? This is the hello world, then what? Then maybe ABCD, then Q. So what's the largest one? The largest one is like, this is the hello world, right? You need to keep track of the longest word and keep checking the next word, whether it's the longest one or the previous one is the longest one. If it is, keep the previous one as this, otherwise update it until it enters the queue. So this is the problem. So how I can write these things? Well, I'm writing a longest word variable here. And since I'm asking the user again and again, I have infinite loop. I'm asking the user with this prompt. And since it is a string, I don't need to worry about converting anything, try and accept. Where is the queue? Break it, checking where it's an is alpha not. If it is not an is alpha, we're returning. Otherwise, we're checking the current word with the longest word. So right at the very first point, our longest word is empty. That means our current word is the longest word. On the next iteration, our longest word is changed, right? Our longest word is the previous word, and then it will check with the next word, so on and so forth. Whenever it enters the queue, we're done. We're breaking from this loop, and then we're checking whether it's an empty, like if the first input is the queue, that means we have nothing here. Then it will print no words entered. Otherwise, it will print the longest word. This is the solution, right? Step-by-step process. This is a perfect solution. But it is not readable, it is not maintainable, it is not testable. It is not a functional program. It is just a program, step-by-step process. Also, there is no docstring. The first thing is the docstring. Then probably I need to find out the steps. What are the steps? First step is done. The next step, it is working. Find out the coherent piece of work, encapsulate it. Now, what I can do here, input, checking whether it's a valid one, and then update the current word to the longest word, like the main calculation of finding the largest one, and then final output. So input, output, exit, validate, and then the main calculation. At least 3, 4, 5 sub task, right? So not necessarily we have to use all 5 tests all the time, but we need to focus the major things. What is the major thing here? At least we need to validate the word. This is the important thing. Go with the first one. I'm writing a function is valid word. If it is alpha, so what kind of function it is? The leap of faith, right? It is returning either true or false, a Boolean function. So now instead of writing all those things, I'm just checking whether is valid word, proceed it, otherwise exit or go to the next iteration. So I'm replacing this one here. If it is valid one, it's invalid, continue, go to the next iteration. If it is a valid, go to the next block. First thing is done. Now, how can we generalize more? Let's see. There's not too many things here, but we can always generalize more ways, like the input thing. So here in the main function, we can write infinite loop gets the input from there and find the first we can validate this input and then find the longest word, which one is longer or not, and then prints the output. But this is also fine, at least readable. But sometimes if you're refactoring too much, like writing a function with only 2 statements, that is too much then. You don't need to. In that case, you can just keep as it is. Now, I have like how many functions? This is our main function. This is our find longest word. And the find longest word gets the input. It checks whether it's a valid one. It will call the is valid function. Here's my is function. And then if it's not valid, keep doing. If it's valid, returns the longest word. Whenever we have the longest word, we'll check if it is not a none, then it prints the longest one. This is how the workflow works. Does that make sense? Now, I can rewrite this code in a different way. So what I can do, I can rewrite this code. So it is working. So first thing is like, is it working or not? So first, if it is the queue, nothing. If it is like SD, so it doesn't take any space. Okay. And Q, the longest word that I'm here. Right. So what I can do, this is my working code. Now I need to refactor it. First, the doc string. Then I don't have to input anything. Then I have to write some function. So before writing the function, I need to write the main function. And just write the path. And then if name equal main. So at least we have a main function. What you need to do, main function, the doc string, the input, process, and the output, right? So what are the input? Input is within the while loop, right? Okay. So while true takes the input, right? Takes the input and then what? It will check whether it's a valid or not. So we are moving these things to that function. Like, well, here's my utility function. Def is valid. If it is a word, I'm checking if it is not alpha, return false, otherwise return true. So if it is not is alpha, then we're returning otherwise true. So let me rewrite these things. If it is not alpha, okay, keep as it is. So what I'm going to do, I'm checking if is valid. Instead of what is alpha, I'm writing is valid. This is my utility function. So I'm done with this one. Then otherwise, I will check the longest word versus this word, right? So I'm writing another function like find longest. I need to provide the word or the current word, I can say. That make more sense. Current word versus as of longest, right? So it will just check if the current word is greater than as of longest word, then return the current word, right? This is the find longest. So here inside the main function, I'm just writing longest word as empty. And then I will check if I will call this function. This function will return what? Return the longest word, right? That means as of current. So as of current is the longest word. Does that make sense? This word is what we are getting right now. And longest word initially empty, later it will update based on the function call. The function calls here, update this one, and then we have the longest word. Now we have the longest word. Here's the input, here's the longest word calculation. Then we have the output, right? So what I can do here, I can just write the output here, or I can call another function. So since it's like 2 lines of code, I don't need to write those things. Write a new function. I just write here. So I have like how many functions? 1 and 2. One function is validating the number. Another function is finding the longest one. So here I'm getting the input, then checking the validity. If it is valid, I'm sending that word with the current longest word, and this word is mapped with the current word. Longest word will map the as of longest word, and it returns the longest word. And finally, when we have the longest word non-empty, it prints the longest word. Let me print it. Q, nothing. Is the here is there. Q. None. That means there are some issues here. Our longest word is always none. So I'm sending, oh, I need to update the longest word. If the current word is the length of that word, what's the problem? This is my current word. Here's my longest word. So, well, now come to the point. I need to test the code, debug the code. Do you know the debugging? What I can do on every iteration, I would like to print the longest word so that I can see, well, whether this particular function is working. Okay. So ASD, as of now, longest word ASD. This one, as of now, it is this one. That's fine. I am here. So as of now, I am here. How about ASD? None. Okay. Can you see the problem? So up to I'm here is fine. When I'm putting ASD, it shows none. Yes.
It only returns if that conditional.
It only returns if it is greater than, then returns the current word. We have to have an else. Else, we need to return the as of one, right? When it is greater, then it returns the greater one. If it is not, we need to keep the current as it is. We don't have the else case, so we need to kill it. SD, I am here. Then ASD, now I am here. See, if it is a bigger one, then a smaller one, still the bigger one. For Q, have the bigger one. Okay. Any question? Now it's time for you to write something with this development plan. What you need to do here, you will start with the working program that repeatedly asks the user for a sentence and reports how many vowels it contains. Then you will improve the program structure by encapsulating and generalizing logic into the function. So what is asking? It repeatedly asks the user for a sentence and reports how many vowels it contains. So what is the input? So first I need to write the basic code, right? So enters a sentence. So right now it is sentence. If the sentence is Q, break it. Right, up to this point, we're good. Now, how we can check whether there is a vowel or not there?
Unless there is a function in Python specifically for that, you can check for, you make it conditional for A or
Yeah,
E. Or
given that we don't have any function, so we'll write our own, right?
Mhm.
So in general, how we can check whether it's a vowel or not? A, E, I, O, U, right? So what I can do, I can convert these things to lower. Or maybe since lower returns the new one, what I can do, this is the original sentence. I can write here original sentence, but our new sentence is the original sentence dot lower. The reason I'm doing is like if I'm writing dot lower, I cannot get the original sentence. So I can keep the original sentence as it is, then converting it to lower to a new sentence. Now, how I can check? If the sentence contains A, E, I, O, U, right? So what I can do, if A in the sentence or E in the sentence, I in the sentence, O in the sentence. Yes, go ahead.
I think that that will return a true or false, right? Like
Yeah.
if that appears. So I think maybe instead we would do for A in a sentence, then you +1 to something.
Okay, that means it returns true or false. That means we're checking whether it is there or not. But our goal is to find how many vowels, right? So we need to count it. So for I need to iterate the sentence for character in sentence. And then I'll check if the character is equal either A or the character is E or I or O or U. That means it is a vowel. So we can count with something, right? But make sure we have a counter before starting the for loop. So we have a counter here that counts whether there's a vowel or not. Okay. Now at this point, if we print the count, this will print the number of vowels in that particular sentence. But the problem is it is an infinite loop. It will keep doing again and again, right? That's fine, I guess.
Got a break condition.
Yeah, that there's a break condition. But if we would like to run it one time, then probably to break after this one. But that will work fine. Let me run this code first. So I'm here probably 4 vowels. So I, A, E, E is good. A, E, I, O, U should be 5 vowels there, right? So other than A, E, I, O, U, whatever is 0. If it is a Q, it's done. But still, Q is a word. But in that case, we cannot use the Q, unfortunately. But we can use a different wording here.
I think I know how many vowels is in Q.
Yeah. This is the
Theoretically,
word.
could you make it so that it's like Q1 because that's likely to be used?
Yeah, or I can say like if it is a 1, it will return. So if there is a 1, then we return or 0. It's not a sentence. But make sure you need to put it here, like if it's a 0 to quit. So this is our working solution. What's the next step? Encapsulation, generalization, and refactoring. Help me to encapsulate this one. I haven't validated here, so probably I need to write some validation, like if the sentence is empty, there's no words, right? Yeah, in the sentence there might be spaces, there might be numbers. That's fine. But empty is not a valid one. What else I can check? I don't need to check any other things, right?
Not really.
Yeah. Now, here's my function, like working program. Naively, I'm writing those code. As you have learned function, you need to generalize it, encapsulate it, refactor it. Help me to do that. Are you writing code on your own computer? Make sure you write the code. Otherwise, I don't allow you to leave the classroom. Yes.
I don't know if it's what you're looking for right now, but from a user point of view, they're just typing a sentence and getting a number. So I think we need to tell them that that is actually that the meaning of the number, that's how many vowels there are in the sentence.
Was that like a number cannot be and like you, so you're not allowing a number inside the sentence?
No, what I'm thinking is, in the print statement, you format it so that it says there are
Oh, okay.
numbers of vowels, so they're not
Okay.
just getting a number and being confused.
Okay. Like this?
Yep.
That's great. But is the point of like, so, what do you say? User point of view, right? But as you are a programmer, you need to refactor it so that you can reuse it. Or maybe you need to write another function called like find the consonant of this sentence. You will just rewrite it. For example, ask you to rewrite a consonant. So what you're doing, you're just copying the whole thing. And then instead of A, E, I, O, U, you're just writing not equal.
You change the ors to and.
Or strand. But is it a good approach? Writing the same thing again and again? Put in a function, at least. So here is a function called like find who I am, for example. Right? So if it's a vowel, V. So by default, it is true, for example, like a default parameter. That means by default, it works with vowel. So we'll check here. If V is like vowel, let me write this thing's vowel. Find who I am, find vowel. If the find vowel is true, then we're doing those things. Otherwise, we're doing the other things. Except some lines of code, right? But still, there's some similar type of code, like count 0. We don't need to use here count 0. Right? For the looping, we're doing the same looping here and here. So what I can do, I can write here, I can write this if vowel true, then doing these things. Instead of count, I can say count vowel. Otherwise, not here. So what I can do here, I can just write a complex if statement. First, I will take if it is vowel and any of them. Otherwise, it's a consonant. Again, from the printing, I do the same thing. How many vowels? So vowel V. How many consonant? Consonant C. So again, we can write some code. If find vowel, if find vowel, then print the find vowel, else this. We're generalizing our code, but still we're not writing any function. Now, if I put everything in a function, count character, again, vowel is true. So by default, we're checking the vowel. And what are the other things? I need to check, get the sentence. Here, what I'm going to do, if vowel is true, this and this, instead of printing, we're going to return is because we are not supposed to print anything. In a function other than the main function. So what I can do here, I will check this. So instead of those lines, I can write here, one is vowel true, another is vowel false. So since true is the default, so I don't need to pass any parameter, or I can. Right? What other things? I need to check the valid sentence here, right? So I need to write another function, dev valid sentence. Here's a sentence. So if it is 0, return valid means like it is checking is valid. So name should be like is valid. So if it is not valid, then return false. If it is not valid, instead of no word, return false. If none of them are, like if it is not going there or there, by default it returns true. So now instead of this, I can check, well, if is valid. Oh my God, sorry. Already past 2 minutes. If is valid, then we're doing those two things. Right? And then whenever we have the number, we can print those things from there. Like what are the value? Here's the result. And here's the result. Make sense? If you haven't written anything in the class, make sure you write it after the class. That's the one exception. Okay. Sorry for that. Sorry for keep you waiting. One last thing is